and welcome to the launch webcast for our 49th Electron mission, set to launch from Pad B at Rocket Lab Launch Complex 1 in New Zealand in just under 19 minutes from now. Today we'll be launching the second of two launches for NASA's climate science PREFIRE mission after standing down a couple of days ago due to out-of-bounds LOX temperatures. Thanks for joining us. My name is Muriel Baker and I'll be taking you through today's countdown to liftoff for the PREFIRE and ICE mission. Currently set for launch today at 3:15 p.m. local time or 03:15 TC. Now, PREFIRE and ICE is the second of two back-to-back launches on Electron to deliver NASA satellites to orbit for the PREFIRE mission. PREFIRE stands for Polar Radiant Energy in the Far Infrared Experiment, and it's a mission designed to measure heat loss from the Arctic and Antarctica to help improve climate and ice loss models that better predict Earth's ice, sea level, and weather changes. The first satellite in the PREFIRE mission was deployed by Electron to its 525-kilometre orbit 11 days ago. After today's second launch and deployment, the two PREFIRE satellites will spend the next 10 months crisscrossing Earth's coldest regions to collect their data. And once they're operating, PREFIRE will make the first full spectral measurements of far infrared radiation, revealing the full spectrum of Arctic radiant energy. Now, those measurements will then be used in climate and ice models to help better predict Earth's sea ice loss, ice sheet melt, and sea level rise. PREFIRE is focused on the Arctic and Antarctica because these polar regions have a big influence on the Earth's temperature. Excess heat escapes from there to space, and the difference between how much heat is released versus how much heat is received from the sun in the tropics is a key influence on the planet's temperature. Better understanding this process and what it means for Earth's future climate is what the PREFIRE mission is all about. Here's NASA to explain more.
The Arctic is warming 3 times faster than anywhere else on Earth.
This is a huge problem, in part because that is enhancing melt of the ice sheet. It's leading to enhanced melt of sea ice.
All of the coastal communities around the world are now seeing sea level rise around them and experiencing increased flooding.
It will impact the future generations. They're going to inherit a planet that's going to be many degrees warmer than what we are today.
We need to have better predictions of how sea level will change, how the weather around the planet is going to change. The only way we're going to do that is to understand how the polar regions are responding to climate change.
We have this considerable knowledge gap in our understanding of Arctic climate.
PREFIRE is going to fill this important gap.
PREFIRE, Polar
Radiant
Energy
in the Far
Infrared
Experiment.
So Earth's temperature is set by a balance between the amount of energy the Earth receives from the sun and the amount of energy that it emits back to space.
Most of the energy that is radiated to space from our polar regions is far infrared energy, and we have no modern satellite observations of this incredibly important energy spectrum. PREFIRE will be deploying 2 CubeSats. Over the course of a year, they're going to be measuring the far infrared energy for the very first time that is leaving the top of our atmosphere.
Each of our PREFIRE CubeSats carry something called a thermal infrared spectrometer that looks down at the Earth and gathers energy being emitted from the planet at different wavelengths.
Just imagine a rainbow. When you see a rainbow, you see the different colors in the rainbow, and what happens is light gets dispersed. Similarly, we see the different wavelengths split up, and you can measure each of these wavelengths, and that's what the spectrometer does. It spectrally separates